When it comes to matrix multiplication, there's one very special matrix, and it's called the identity matrix. What is this matrix? Well, we call it IN, and this is the n by n identity matrix. All right. And what this is it's a matrix that consists entirely of zeros and one. Right? So it has ones on the diagonal, on the main diagonal, and zeros elsewhere. Right? So the way we would write this are some examples of it. Let's say first 1 0 0 1. This is the 2 by 2. The 3 by 3 identity matrix is 1 0 0 0 1 0 0 0 1, right, and so on. So this is always a square matrix. So it always has an equal numbers of rows and columns, right? The way we would normally write this with the entry notation that we had before. So we need something that I'm going to call delta ij. And those of you in physics either have or will see this at some point. Delta ij is equal to 1 if I equals j, and 0 if I is not equal to j. Then we say that in is just this. Right? So that's just to give you some notation for it. Right, so what properties does the identity matrix have? Well, it turns out that it's the multiplicative identity. Right? So properties of the identity matrix. Right? What this is, or what these properties are, there's two of them. So A is going to be an m by n matrix. Then, the first thing that's true is that if we take A and we multiply it by the n by n identity matrix on the right, we just get A back. Right? The other property is if we take the m by m identity and multiply it on the left, or multiply it on the left side of A, we get A. So what this is saying is there's an appropriate size identity matrix for either side of a matrix, and when we multiply any matrix by the identity, it doesn't change it. Right? So this should remind you of multiplying by 1 when it comes to numbers. So the identity matrix is sort of the 1 for matrices. All right, so hopefully that makes sense. And what we'll see later on is this actually plays a big role in allowing us to solve systems of equations and to ultimately find what's called the inverse of a matrix. So we'll end this video here, and then we'll talk about some uses of this matrix algebra in a bit.